Here we're going to take a look at average value using intervals. And I ultimately want to find out what value of x on the interval 0, 3 leads to the average value of the function. And so let's take a look at the graph of the function. So here from 0 to 3, I see the function is sometimes negative and sometimes positive. And average, remember, is the sum of your values divided by how many values there are. Now, in this case, since I have a continuous function on an interval, there are infinitely many numbers between 0 and 3. Right? So that's a continuous interval. So to find an average value in that case, we have basically infinitely many vertical lines here that represent the function value y. And we can't divide by infinity, that won't work, but you end up dividing by the length of the interval. Right? And to get those infinitely many lines, that's essentially the area we will integrate. Okay. So the average value of the function is going to be the integral from the start x value to the end x value divided by the width of the interval. So that's how we take the idea of average for a continuous function on an interval. And a continuous function on an interval has infinitely many x values in which you could play with. So what we need to do then is find the average value. So the average value of f in this case is going to be the integral from 0 to 3 of our function 2x squared minus 1 with respect to x. And then once we get that value, then we divide by 3. That gives us the average y value on that interval. It is important here to consider that we want all of them in here. And in this case, it's okay that some of them are negative and some of them are positive. Okay? That is important. All right, so no absolute values are involved here. This isn't like total area. So we need an antiderivative. So I'm going to write that as 1/3 times the interval from 0 to 3. Actually, I'm going to use the interval at this point because we can do an antiderivative pretty easy. Antiderivative of x squared is x cubed over 3, so we'll get 2x cubed over 3 minus x, and we want to evaluate that from 0 to 3. Pretty straightforward. Plugging 0 into either of those is nice. So in the end, I'm just going to get 1/3 times the right-hand value plugged in, which is, let's see, 3 cubed is 27, divided by 3 is 9. 9 times 2 is 18, and then we're going to get a minus 3, so that's at 15. And then if we plug in 0, we get 0 minus 0, which is still 0. 1/3 of 15 is, 5 on a good day? All right, so we're finding the average y value is 5. All right, so next thing to consider is which x value will give us 5. Okay. So that's a pretty straightforward problem for GeoGebra. We could just say, hey, what if y equals 5? Y equals 5, there we go. That's the average value of this function. Notice it is steeper here, shallower there. And we want to know what x value goes with that. So we can see here it's somewhere between 1.5 and 2. So now we need to solve the equation. When does 2x squared minus 1 equal 5? Adding 1 to the other side gives me 6. Dividing by 2, x squared is equal to 3. And so x is plus or minus the square root of 3. Now I'm on the interval from 0 to 1, so really I only care about the positive one. So I just want this right here. So double check there. What if I were to graph x equals square root of 3? And I get precisely that point that I want. So I found that if x is equal to the square root of 3, that will lead us to the average value of this function, which happens to be 5. All right, pretty easy example. That's it for this one.